Hello, my name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for the GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 165. Page 165, or rather page 166. Page number 166. And today is our lesson number 105. We're going to do the very first problem on the page, problem number 99. In problem 99, they tell us, that x times 2x plus 1 equals 0. So here we have one quantity x, and here we have another quantity 2x plus 1, and we are told that their product is 0. When the product of two quantities is 0, there are two possibilities. One is that, for example, if a times b, we are told that equals 0, that implies that either a is equal to 0 or b is equal to 0. And of course there is one more possibility, which is they are both equal to 0. So that's what we will do here. So this implies that either x is equal to 0 or 2x plus 1 is equal to 0. Well, if 2x plus 1 is equal to 0, if we solve for x, we find out that 2x equals -1 and x equals -half. So which one is it? Is x equal to 0 or is x equal to -half? Which one is it? But that's where the second bit of information comes into handy, because they give us one more equation, and that equation also will have more than one values of x, and we'll ask ourselves which of these two values from the first scenario coincides with which of the two values in the second scenario. Whichever value is the common value, that's what x is. So in the second scenario, they tell us that x plus half times 2x minus 3 equals 0. Well, if that were the case, then this part implies that x plus half equals 0, or 2x minus 3 equals 0. Well, if this were true, if x plus half equals 0, that implies that x equals -1/2. That's it, we're done. Since x equals -1/2, which is exactly what we found here, it really doesn't matter what x comes out to be here, what the x came out to be here. That is not the value of the x that will satisfy both equations. We need the value of x that's going to satisfy both equations simultaneously at the same time. And that value is x equal to -1/2. That's it, that's our answer. X equals to -1/2. Let's do the next one, shall we? Number 100. We're done with this question. In number 100, they tell us that the reading of n plus 1 means 10 times the amount. Let's see, how do they phrase it? That corresponds to n. Now let's first understand what this means actually before we actually try to solve the problem. This question, not what I'm about to say, the GMAT does not assume that knowledge, but just for your knowledge, this question has to do with what is known as I'm not going to pronounce this name. I'm not going to pronounce the guy's name because I'm going to end up mispronouncing it. But I have no choice. I have to pronounce something like Richard's scale, I believe it's pronounced. which measures the intensity of earthquake. And in the measurement of earthquake intensity, this is how the meter goes. This is how the meter starts. The meter starts out with 1, 2, 3, 4, and 5. Now each time you move from 1 to 2, moving from 1 to 2 is a multiple of 10. So what do these numbers represent? 1, 2, and 3. What do they represent? They represent that they have to do with the multiples of 10, as I said. For example, 1 here is same as 10 raised to 0, because any number raised to 0 is 1. 2 here has to do with, this is not right. I didn't mean to start from here. We have to go one more further here. Here is your 0. And start with 10 raised to 0, which is actually 1. And then 1 here is 10 raised to 1. And 2 here is 10 raised to 2. And 3 is 10 raised to 3. So in the scale it shows up as 0, 1, 2, 3, 4. But 0 actually is same as 1. And 1 actually is same as 10. And 2 is same as 100, and so forth. This is 1000. So the reading that you see on the scale, it shows you the number of zeros in the reading. In other words, an earthquake of a magnitude of 7, is actually 10 raised to 7, which is 10 times as powerful as an earthquake of a magnitude of 6. An earthquake of magnitude of 6 going from 6 to 7 is a big deal. It's a very big deal, because the earthquake now is 10 times as strong as the one that was at magnitude 6. An earthquake of magnitude of 9, would be devastating, because it is 1,000 times as strong as earthquake of magnitude 6. That's what they're talking about here. The reading of n plus 1. N over n is whatever number. And if n happens to be 3, what they're telling you is that a reading of 3 plus 1, which is 4, what they're telling you is that a reading of 4 means it is 10 times as the amount that corresponds to 3. We are assuming that the n is 3 here in this scenario, in the example that we made up. So a reading of 4, 3 plus 1 here, a magnitude of 4 comes here, which is 10 raised to 4. And that is, they're telling us, is 10 times the amount that corresponds to 3, because 3 would have been 1000, which is 10 raised to 3. The question simply is, it's a very simple question, the question simply is, how strong, let's see how do they phrase the question. On that scale, the intensity that corresponds to the reading of 8 is how many times as great as the intensity that corresponds to the reading of 3. Well, let's find out. Let's find out. So here's our, we're going to start with 3 here. 3, 4, 5, 6, 7, and 8. Let's find out, shall we? So these are all zeros. 0, 0, 0, 0, 0, and then 1. Voila. So this is the magnitude of 3. This is the magnitude of 8. How many times stronger is it? It is exactly 100,000 times stronger. It is exactly 100,000 times. 100,000 times. Or as they put it, 10 raised to 5 times, because there are 5 zeros. 1, 2, 3, 4, and 5. That's it. So a reading of 3 is 100,000th of a reading of 8. What I meant to say was the other way around, because that's how the question is asked. The question is asking a reading of 8 is how many times the reading of 3. The answer it is 100,000 times the amount. A reading of 8 would be, here we have 6, 7, and 8. 8 is 10 raised to 8. And 3 is exactly what it says. It's 10 raised to 3. It's just 10 raised to 3. 10 raised to 3 versus 10 raised to 8 is, how do we go from 10 raised to 3 to 10 raised to 8? You have to multiply it by 10 raised to 5. That's how strong it is. It's 100,000 times strong. That's all it is. I don't know how much more to explain to it. I know in the beginning I sort of messed it up how I started out here. One more time, this is where the scale starts. The scale starts with the power of 0, 10 raised to 0. 10 raised to 0 and the ordinary number will be 1. So in the ordinary number, ordinary scale that we use, it starts at 1, then it goes to 10, 100 and so forth. 1 represents the 10 raised to 0, then 10 raised to 1, 10 raised to 2 and so forth. That's what the scale is. Let's do one more, shall we? Let's do one more. I'm going to leave that alone if you're interested. Let's do the next one. So one more time here. We started out with 3, 4, 5, 6, 7 and 8. All you have to do is start putting 0. 1, 3, 4, 5. There you go. It's 100,000. It's 100,000. 10 raised to 5. The next problem is 101. In 101 they give us 1, 2, 3, 4, 5 observations, and they go something like this: n plus 1, n plus 2, n plus 4 and n plus 8. Question is, mean is how much greater than the median? Mean is how much greater than the median? Well, let's find out the mean and the median, shall we? Now the very first thing we have to understand, the very first thing we have to be smart about here is that because of the fact that n appears everywhere, n appears in every observation, n appears in every observation, therefore it plays no role. It plays no role. For example, let me give you a simple example here. 3, 4 and 5. Very simple example. If somebody were to ask you what's the average of 3 plus 11, 4 plus 11, 5 plus 11, well, we don't have to pay attention to the 11 part. Just realize that the average of 3, 4 and 5 is 4. Therefore the average of these three numbers is just 4 plus 11, because 11 appears everywhere. So you just stick the 11 at the end, which is what we're going to do here. N appears everywhere, just ignore the n. So we have, this guy is 0, because it's n plus 0, so it's 0. This thing, the very first one, I'm writing this as n plus 0. So we have 0, then we have 1, 1, 2, 4 and 8. Voila, there are 5 numbers, and since there happens to be an odd number of numbers, median is very easy to figure out. Median is the middle guy, that's our median. Now let's find out the average, shall we? The average or the mean equals 0 plus 1 plus 2 plus 4 plus 8 over 5, because there are 5 of them. 0 plus 1 is 0 plus 1 is 1, 1 plus 2 is 3, 3 plus 4 is 7, 7 plus 8 is 15 over 5, which is 3. So can we tell now mean, the mean here is how much greater than the median? Well, it's only one greater. Mean is 1 greater than median. The answer is B. That's it, we're done. I will see you tomorrow, okay? Bye now.